Here's kind of some proof from Desmos that the answer to this problem is the sine of x. All this simplifies to the sine of x because the graphs of these two functions are identical. So the question is, how do we get from here to here? And you made the comment, I don't understand how to figure out which identity to use. It is a little bit of an art form. There's more than one way to do some of these problems. But what you have to realize is that all of these identities, not just the Pythagorean identities, I'm using this as an example, can take on different forms. In other words, if sine squared plus cosine squared equals 1, that's identity 6, then these are other forms for that same identity. Sine squared, if I subtract cosine squared from both sides, I get this. So anywhere I see 1 minus cosine squared, I can replace that with sine squared. Similarly, cosine squared equals 1 minus sine squared. If I wanted to, I could even take the square root of both sides, and I'd have yet another identity. So for this second Pythagorean identity, identity 7, tangent squared plus 1 equals secant squared, another way to write that is like this. That's a different form for the same identity, which I got by subtracting 1 from both sides. Okay, and so the directions to this problem say to convert everything to sines and cosines, and then see what happens. Well, secant squared minus 1 is this Pythagorean identity right here. One way to rewrite that is secant squared minus 1 equals tangent squared. So I can replace this with tangent squared. And I still have the cotangent of x sitting out to the right. And while I'm at it, I'm going to convert this tangent of x to sine over cosine. There it is right here, identity 4. So sine over cosine. And then I'm multiplying that still by this sine. And then I have a plus cosine in the denominator. So really, I've used two identities at this point. One for the Pythagorean identity and one for this quotient identity. Now, tangent squared is the same. Tangent is the same as sine over cosine. So I can and I'll go to blue here. I can rewrite this as sine squared over cosine squared. And cotangent is cosine over sine by identity 5. And in the denominator, I've got, well, these two numerators multiply to give me sine squared. And I still have cosine of x in the denominator. And I still have this plus cosine of x sitting out to the right. Now, at this point, I've converted everything to sines and cosines. I can do some canceling here. See how one of these sines cancels out? And one of these cosines cancels out. And I still have sine squared x over cosine of x plus cosine of x. Now the question is, what's the easiest way to simplify this complex fraction? My preference is to multiply numerator and denominator of the big fraction by the least common denominator of all the little denominators. So I'm going to multiply the numerator. The LCD of these little denominators is cosine of x. So I multiply top and bottom of the big fraction by cosine of x. I'm allowed to do that because I'm multiplying by 1, and 1 times any number is the number you started with. And what happens is, in the numerator, these cosines cancel out. Let me move this out of the way here. And so I've got sine of x in the numerator. And in the denominator, I have to distribute this cosine of x times each term in the denominator. So when I take this times the first term in the denominator, the cosines cancel out and I get sine squared. And when I take this cosine times this second term in the denominator, I get cosine squared. And finally, sine squared plus cosine squared is always equal to 1. No matter what values of x you put in there, that's identity 6. So you get sine of x over 1, which is just the sine of x. That's your answer. Okay, so try to get a copy of these identities in front of you and get used to the fact that they can take on different forms. There you go. Hope that helped. And if you have any questions, post a comment.